Greetings. This is the voiceover for the homework assignment, chapter 3, section 1. To be quite honest, in section 3.1, we're dealing with things that you probably had when you were in middle school, if not that, maybe even in fifth grade. Mean, median, and mode. All right. It's not until we start getting into standard deviation and percentile and quartiles that it gets a little more difficult, but not much. So here we go. Andrews asked his 7 friends how many cousins they had. The results are listed below. What's the mean? Mean is the average. All right. So I could have just taken those numbers and actually maybe even added them in my head or added them on the calculator. And it's what? 3, there's 6, 7 numbers. Take the total, divide by 7. What I did here was to put these 7 numbers into a list. I put them into list 1. And then once I had them in, I went back to calculate, and one variable stat, and right at the very top is my X bar. X bar denotes the mean 9.4. Notice all the answers had 1 decimal point. So you're putting the numbers into your list. You're going to have 1 decimal point. So it's going to be 18.0, 12.0. And why you're putting 1 decimal point? Because as we move on, you want to be precise. Some answers will all be in 2 or maybe sometimes even 3 decimal points. So you want to make sure you go to mode and set your calculator to the appropriate number of places. Number 2, we're looking at last year, 9 employees of electronics company retired. Their ages, once again, you could have just added that with your calculator and taken the sum and divided it by 369. I here again put it into a list. Here again, I like using list 1 because I can remember what it is. Put the 9 numbers in there. Go back to calculate and 1 variable stat. And my mean is 58.3. Same exact thing in number 3. Here I actually show you putting the numbers into a list with 1 decimal place because the answers all have 1 decimal point. And there's my mean of 464.2. Number 4, median. Well, the median is the middle number, provided, of course, your numbers are in order. If you have an odd amount of numbers, you'll have an exact middle. If you have an even amount, you have to take the 2 middle ones once they're arranged in order from smallest to largest and take the 2 middle ones and average them out. Here you had 7 numbers, so 59 was the one right in the middle. 3 smaller than 59, 3 larger than 59. Store manager kept track of newspapers sold, but notice the original list is not in order. I took them and I arranged the 7 numbers in order. Oh, there it is. There's the middle number 214. 3 smaller and 3 larger. All right. Here again, I could have put those numbers into my calculator, into a list. The calculator would have given me the median, but all kind of ways of doing. You want to keep it as simple as possible, but there are multiple ways. I don't think it was a big deal of taking 7 numbers and arranging them in order and finding out that 214 was the middle one. Here, maybe I would have put these into my calculator and had it give me 26 for the median. What I did was just to write the numbers all down and put them in order, and then there were 2 middle numbers. Since there were 2, 4, 5, 20 numbers, 20's even, so you had 2 middle numbers, 1, 2, 3, 4, 5, 6, 7, 8, the 9th and the 10th. All right. 26 plus 26 divided by 2 is 26. There's your median. Mode is probably the easiest thing going. What number occurs most often? Negative 43 did here. Here there were 2 numbers, the 92 and the 56 both appear twice. This set would be known as bimodal. Number 9, the number 66 appeared most often. It appeared twice. And number 10, there was no age that appeared any more frequently than anything else, so there was no mode. Number 11, here's the deal. Whenever you're given a frequency distribution, you're told that 17 employees make between 5,000 and 1 in 10,000. You don't have specific values, so what we do is we first find the midpoint of that class. Once I find the midpoint of that class, I add the class width. The class width here is 5,000, so 7,500.5, 5,000 more, 5,000 more. You have to find the midpoint when you're given a frequency distribution. You enter the midpoints in one list You enter the frequencies in a second list, and you go to one variable stat, and it gives you your mean. Now, notice the discrepancy here. This is wrong because the answer was there was no 50 cents. So this is very rarely does this happen. Usually the answers, in most cases, they're spot on, but there was a discrepancy here. All right, so now if you're using an 83, it's not going to prompt you for L1 and the frequency L2. When you go to one variable stat, it just flashes. You've got to physically put in L1, second function 1, comma, second function L2, or number 2, which will prompt you, which gives you L2 on your calculator, then hit enter. So the 83 is a little bit different, and I have a video that shows the discrepancies between the 83 and 84, specifically how the 83 does not prompt you. You've got to remember to put in the midpoint first, followed by the frequency. Same thing with number 12. I had to find the midpoint. Once I found the midpoint of the first class, 34.5, I found that by taking 30 plus 39, 69.5, dividing that by 2. Now, rather than keep on doing it, I noticed that the class width here is 10. So once I found the first midpoint, I kept adding 10 all the way down. I put that into one list. I put my frequencies in list 2. Hit one variable stat, 55.7. Spot on. Identical number 13, I had to find the midpoints first because I got to be able to put that into a list. All right, if you're doing it any other way, you're doing it wrong. So it takes some time to find these midpoints. It takes time to find these midpoints. Once you have them, you put them in L1, put them in L2. Now, could you put it in the other way around? Yeah, but you'd have to remember when you put them in your calculator, you would have to say list is L2, frequencies L1. It gets confusing. So be consistent. Put the midpoints in L1, put the frequencies in L2. All right, same thing with the 83. You'd have to actually go second function number 1, comma, second function number 2, which would prompt the calculator to put in L2. All right, weighted averages. Well, we know that the weighted averages is the sum of all the scores times their weights divided by the summation of their weights. Now, in most of the problems we see, the summation of their weights is 100, but that doesn't have to happen. All right, a professor could have the sum of all the weights being 130%, 140. All right, but in most of these cases, the denominator works out to be 100%, which is the whole number 1, but it does not have to be. So Elaine got 71, 75, 64 on her quizzes. She had a 60 on her final exam. Each quiz was worth 25 points. And, each quiz was worth 20%, and the final exam was 40. So it's 20% times 71 plus 20% times 75 plus 20% 0.20 times 64 plus the final exam, which you received a 60, was worth 40%, divided by the sum of the weights. Now here again, if you add all this up, this becomes just 1. All right, 100%. It doesn't have to be. And doing all that, we came up with a 66 for a weighted average. 15, student earned grades of daily are 92, 79, so forth on 4 regular tests. 79 on the final, 88 in class projects. Your combined homework grade was 87. The 4 regular tests were worth 40%. That does not imply that each test is 40%. Is that the sum of all of them? So if there are 4 of them, they're worth 40%. Each one was worth 10%. So I just went a little differently. I took my 10% and then I multiplied in parentheses the sum of all the regular tests. The final was worth 30%, 0.30 times the score plus project 10% times the score that she got, plus the homework was worth 20% times the score she received. All right, and then divided by the sum of the weights. And once again, the sum of the weights add up to be the whole number 1. If I did that all out, I came up with 83.7. All right, weighted averages, and there's the answers right there. Hope this helps.